Hey guys, so today, topic 7, we're going to talk about standard deviation. So first off, what is standard deviation? Standard deviation is a measure of the spread of the scores around the mean. So it tells you the typical distance from the mean. So on average, how far away are the points from the average? Now your standard deviation is what we call a measure of variance. And there's multiple measures of variance that we could use. So a measure of variance is a quantitative measure used to describe the spread of the data. So it's a number that tells how your data is spread out. So examples of measures of variance, your range, which is your largest minus your smallest, your IQR, which was from Algebra 1, your interquartile range, your standard deviation, which we're going to go over today, and your variance is also what we're going to go over today as well. Okay, so these are just different methods to tell how spread out your data is, and your standard deviation talks about how far away or the typical distance from the mean of your points. So the next slide, this did not print very well on this, but it's giving you the steps to find your variance and standard deviation. I find it's easier to work these out. So problem number 1, what is the mean, the variance, and the standard deviation of these values? So the first thing you want to do is find the mean of the data. And we say this is x bar. So x bar, our mean, is what we get when we add these all up and divide by however many we're adding. So we're going to add them all up and divide by 5. And I get that this is 7.4. So my mean, which we say is x bar, is 7.4. The next step is we're going to find the difference. This, I think, says x minus x bar for all of the data points and the mean. So I'd like to kind of create a table. So I left a blank spot. You'll want to leave some room for problem number 2. So I'm going to list off all of my x data points first. So 6.9, 8.7, 7.6, 4.8, and 9.0. The next thing I'm going to do is subtract the mean from each one of these points. So each x value, I'm going to subtract the mean from. So I'm subtracting 7.4 from each one of these points. So when I subtract 7.4 from each one, I should get negative 0.5, 1.3, 0.2, negative 2.6, and 1.6. So this is how far the data are from the mean. Now, if our standard deviation is on average, a lot of people are like, oh, let's just average these up. But if we average these up right now, we'll get 0 because we have some positive and negative values in there. So the reason we're not averaging them is because the positive and negatives will all cancel out, and this will end up being 0. So what we're going to do then is to make them all positive, our next step is to square each value. So I'm taking my previous column and I'm squaring it. And this way, every term will be positive. So in my calculator, I'm just going to go ahead and square each value. So when I do this, I get 0.25, 1.69, 0.04, 6.76, and 2.56. Now what we can do is we can average these to get an average distance. So I'm going to add them all up, and then I have to divide by 5. So let's go ahead and add them all up real quick. So when I do that, I get 11.3 divided by 5 means my average is 2.26. 2.26. Now this number, and this isn't our standard deviation, it's not our final step. This is what we call our variance. So our variance, which is denoted as a lowercase sigma squared, is 2.26. Now to get our standard deviation, remember it's how far the average from the mean. So we couldn't use this because then if we add these all up, we'd get 0. So what we did, we squared them and then found the average of here. So what we need to do to go back, we're going to take the square root. So our standard deviation when I take the square root is just going to be a lowercase sigma. And this will be the square root of 2.26. Which will give me approximately 1.5. So I got my variance was 2.26, and my standard deviation was 1.5. All right, so I'd like you to try this. You try. And what I want you to do is go ahead and, if you're doing any kind of rounding, round to 2 decimal places throughout. So that in the end, you're correct within 1 decimal point. Go ahead and pause the video. Should get your mean is 69.83. All right, go ahead and check your answers. And then I'll go and move to the table as well. So you can, if you didn't see the table earlier, you can see them. All right. So problem number 2. The table displays the number of U.S. hurricane strikes by decade. What is the mean and standard deviation of this data? Hopefully we kind of understand how to do it. It's a little bit tedious. So I'm just going to go ahead and give us the answer to this one. If you'd like to check it and try it on your own, you're more than welcome to pause the video and try it. We should get our mean is 17.6 and our standard deviation is 3.5. So in a data list, every value falls within some number of standard deviations from the mean. So for example, if the mean is 50, so remember your mean is going to be, it's the average, it's the middle of your data. So if my mean is 50, and if the standard deviation is 10, so if I go 10 to the right and 10 to the left, any data between 40 and 60 is within 1 standard deviation from the mean. If I could go another standard deviation, so if I add 10 and subtract 10. So here, any data between 30 and 70 is within 2 standard deviations from the mean. And I can do this however many times I want. I can do it again. So between 80 and 20. I'm running out of room on the bottom. So any data between 20 and 80 is within 3 standard deviations from the mean. And I can do it again, but then I'll run out of room. Oops, so this should not say problem 1. It should say problem 3. So use the U.S. hurricane strike data from problem 2. Within how many standard deviations from the mean do all data fall? All right, so let's remind ourselves. Our mean was 17.6, and our standard deviation was 3.5. So first, let's find the boundaries of within 1 standard deviation. So if I have 17.6, and I add 3.5, and 17.6 minus 3.5. So my bounds would be any value that is between 21.1 and 14.1. All right, so let's go back and find out how many of our data fit between 14.1 and 21.1. So between 14.1 and 21.1. So it looks like, if I count these up, I have 9 pieces of data fit within 1 standard deviation. So 9 data points are within 1 standard deviation from the mean. All right, so it didn't fit all of our data points because we need all 15, so let's do it again. So I'm going to do 17.6 plus 2 times 3.5. Or I can just add 3.5 to the 21.1. And then I'll do 17.6 minus 2 times 3.5. Or again, I could subtract 3.5 from my 14.1. So I should get any data point between 10.6 and 24.6. So let's go count the data points between 10.6 and 24.6. All right, so between 10.6 and 24.6. And it looks like all of our data points are between those two numbers. So it looks like all, which would be 15 data points, are within 2 standard deviations from the mean. Now, if it wasn't, then I'd have to add another 3.5 and subtract another 3.5, which would be all right. All right, so go ahead and try start working on your homework, remember that you should always be showing your work. Okay, so you should be making a table. If it's asking you to find your standard deviation, you should not simply write down the answer that it gives you on Canvas. All right, have a good one.